In this video we're going to talk about the importance of methods, and to highlight the benefits of using methods I've created a small example program called Lesson 10. To begin with, I'll create the application in a similar style to what we've been doing up until now, and that is to write all the code in the event handler methods. And then we'll start over and create the application again using methods that we create ourselves to better organize the code and make it more flexible and maintainable. Now, looking at the form that I've created, you see that we have a text box that will allow the user to input the weight of an item that needs to be shipped, another text box that allows the user to enter the distance, how far the item needs to be shipped, and then we'll calculate the tax and display the totals on the right-hand side of the form. Now, additionally, there are three command buttons along the bottom of the form. The first calculates the cost to ship within the United States, the second calculates the cost to ship in Great Britain, and the third calculates the cost to ship in Canada. Now I'm just going to make up some simple formulas to determine how much it will cost to and what the tax would be to ship an item. And by the way, I'm creating very simple calculations here. This is obviously a fictitious example, but for our purposes this is going to work just fine. So let's get started by opening up a code view, and to do that I'm going to double click on the design surface somewhere, and the first thing I'm going to do is paste some code into our code window that I had on the clipboard. The first constant that I pasted in was the U.S. tax amount, the second is the Great Britain tax amount, and finally the Canadian tax amount. Now, do you remember what a constant is? We didn't spend a lot of time talking about it, but a constant is a named value that never changes. It helps us to avoid coding magic numbers into our application. If a magic number changes, such as a tax percentage, then all we'd have to do is change it in one place in our code. So we have several constants that contain the tax rate for the various countries, and we'll use them throughout the remainder of this example. Now, the next thing I see here that I've only got the event handler for the Form 1 load event. So what I'm going to do is go back to my designer surface and double click the Calculate US button, which is named BTN US, and you can see that now I have, by double clicking that button, I get the event handler shell for our BTN US underscore click event. And it's here that I'm going to paste in some more code that I've created in advance. You can see the first 5 lines of code are where I dimension variables for the weight, the distance, the subtotal, the tax, and the total. The next 2 lines of code, the weight equals double.parse txt weight.text and distance equals double.parse txt distance.text. These are basically taking the values that the user types in to the user interface and allows us to take them from their string format and convert them into a type of double. This will allow us to perform calculations with them later on. If we just left them in their string format, the calculations that we try to do would not work correctly. The next line of code, subtotal equals weight times distance, is how we're going to determine what the shipping cost is for a given item. We're going to take the weight of the item and multiply it by the distance. Again, this is a very simple example, just for the purpose of illustration. The fourth line of code there, tax equals subtotal times U.S. tax amount. We're taking our constant for our tax amount, which is a percentage, and multiplying it by the subtotal to get our tax. The fifth line of code, total equals subtotal plus tax. Pretty obvious, just gives us the subtotal plus the tax, so we have a final amount that we will charge the customer to ship the item within within the United States in this particular instance. The final 2 lines of code display the tax and the total respectively to the end user on the user interface using the label controls. The string.format statement allows us to put a little $sign before the number, and also to round off to 2 decimal places at the end, or to make sure that there's always 2 decimal places. And this will make it look like currency, specifically that C letter in the format string in the first argument of that method. So we're taking our tax, which is a double, and our total, which is a double variable, and we're converting them into a string in a very specific format that makes it look like currency and displaying those to the end user. So now let's run the application just to make sure that this works. We'll put in the number 8 and the number 9, and we'll click the Calculate US button. You can see we have our tax amount and our total amount. Now we can click the other buttons, Calculate Great Britain and Calculate Canada, and these don't really do anything, so let's rectify that. And the way we're going to rectify it is to first double-click on each of the buttons in the designer surface so that we get our little event handler methods. And then I'm going to just basically copy. I can do it purely with keyboard shortcuts, hitting the Control key and the C to copy, and then to paste it, the Control then V key on my keyboard. But I'm going to also show you how to do this from visualstudio.net. Select Copy, and then go here and select Edit, Paste, and we'll do the same thing here as well. Edit, Paste. Now the only thing that I really need to change to make this work is I want to remove, in the case of the Great Britain button click event, I want to change this from US tax amount to GB tax amount, and then the same would be true for Canada. I want to change this from US to CA. And now I'm going to run the application again to make sure that it works. We'll type in 8 and 9. Calculate US, calculate Great Britain, and calculate Canada. Okay, so now we've set ourselves up for a little discussion on why this may not be the best way to structure our code. Now, let's just use a real-life scenario where the requirements change for the application. What if my requirements change for calculating the shipping cost? What if I need to change the way that the subtotal is calculated? Maybe I need to modify the subtotal calculation to charge only half of the weight times the distance by adding a times 0.5 at the end of that line of code right here. Now, in order to calculate this correctly, I'm going to have to remember everywhere where I've used this formula, weight times distance, and find it in the code, and then make the proper change, again here in Canada as well. This is exactly how bugs can sometimes be introduced into an application, because you may forget to make the necessary changes to all the places where the code needs to be changed. Now obviously this is a fairly simple example, and it's not hard for us to remember to change the code in all 3 places. However, most applications are not this small. So our approach of copying and pasting a big section of code and changing just those parts that are different has an inherent problem. That is that if we need to make changes to it at some future point in time, we may forget all the places that we need to update, and thereby subtly introducing errors into our program. The fact that I had to go to 3 different methods to make a simple change, like modifying the way that a calculation is performed, should be a red flag to me that I didn't write the code in a very modular fashion. Now, to emphasize this point, let's introduce yet another new requirement to our application. As you begin writing applications, users will undoubtedly request lots of new features, and so the way that you structure your code will determine how easy or difficult it is to make those requested changes. So in this case, let's add a new label onto our form in order to display the subtotal. So let's go to our designer surface, go to our toolbox, and drag and drop a label onto our designer surface and put it kind of aesthetically in the right spot. And let's go ahead and clear out the text of that label for the time being, and then also change it to LBL subtotal. So now to display something in this label, I'm going to have to go back to my code view and go total.text equals string.format. Give it our format string. And now I need to remember to place it in all three places, just like I did last time. And then I'll want to run the application again. Uh-oh. So now I've just introduced bugs into three different spots by just copying and blindly pasting that code into the first place without even testing it. So now I got to go through and find all the spots where I made that mistake. And you can see the point I'm trying to make here is that it can get very hairy very quickly if you don't take a more structured approach to how you create applications. Let's try it again. Should work this time. Okay, seems to work just fine now. But what disturbs me is my approach to this problem. When I needed to make a fundamental change to the display of information on the screen, it was fairly involved, and when I made a mistake, I had to go back and look through a lot of code. Again, admittedly, this is a very simple example, but at least for the program size, I had to look through a lot of code. I had to make changes in each of three different locations in code and fix bugs in each of three different locations in the code. And so I asked myself, isn't there a better way to do this? And the answer is obviously yes. If we were to restructure the code and employ some custom methods, this all becomes a lot easier. So what I'm going to do right now is I'm going to cut out all this code and start over from scratch. Just get rid of it all, except for, the event handlers themselves, just the framework there, and just take everything else out and start over from scratch. I'm going to pause the video right here while I do a lot of typing. Actually, I changed my mind. I'm going to go ahead and walk you through how to create methods, and so we'll take a little slower pace. So let's start by creating a method that simply calculates the subtotal for me. So here we go. Okay, you might be saying to yourself, wow, that was quite a bit of typing, and I suppose as you're getting started that might be true. You'll definitely improve on your touch typing skills as you begin to code on a daily basis. But let's break this down and inspect each of the parts that we've declared in this method. First, I've declared this method to return a double. Let me move this over a little bit. I've declared this method to return a double. How do I know that, first of all, this is a method? Well, this might become clearer once we look at the next few lessons, but one clue is that there's a named block of code enclosed in curly braces that return a value. The value could be calculated, could be looked up in a database, could be an object, or any of a myriad of other possibilities. But let's just keep it simple for now, and you'll see plenty of examples of other methods throughout the rest of this video series. In this case, that first double keyword in that line of code returns a value of the data type double. So when this method is executed, the last thing the method will do is return a value of type double. Additionally, there are two parameters that are separated by a comma, double weight and double distance. Parameters are values that you pass into your method. So whenever we call our method, like we'll do in just a moment, we'll be required to pass in the values weight and distance. And we can name these parameters anything we like, although keep in mind that there is a suggested naming convention that we should follow. For now, I just want to focus on the purpose of parameters and name them something fairly obvious like weight and distance. So what I'm going to do in this method is fairly simple. I'm just going to return the weight multiplied by the distance. Again, this is a very, very simple method since it only has one line of code and the calculation is fairly straightforward. We're just doing this for the sake of example here, and depending on the complexity of business rules for a given country or company, the calculate subtotal method might require dozens or hundreds of lines of code. So we're keeping this very simple. And that's all there is to it. Notice we use the return keyword to pass back a value once this method is finished executing. Now I'm going to create another method. And this time we have a void method. As opposed to returning a double, we're going to return void. Well, what is void? This simply means that we return no values once the code within the method block is finished executing. Now, why did I create a void method instead of a method that returns a value? Well, in this particular case, all I really wanted to do is display the results in the labels on the Windows form, and I didn't want anything else to be returned. That just wasn't simply the reason for this method. It'll just perform a set of instructions, then quietly finish. So in the case of this method, all we want to do is just display the result in label control using this line of code. So we created two new methods, calculate subtotal and display result. So let's try to use these within our BTN US click event right here. Now we'll need to calculate our subtotal, and to do that I'm going to call my calculate subtotal. Then I'm going to use an open parenthesis, and when I do, notice that it gives me in IntelliSense the arguments that this particular method is expecting. It's expecting a weight and a distance. Now it just so happens that these arguments are named the same thing as my local private variables that I've used to represent the same thing, weight and distance. It doesn't need to be named the same. That was purely a coincidence. And then finally I want to display the results to the end user, and I'm going to pass in subtotal. So let's run our application and type in 8 and 9, and you'll notice that our calculation is correct and it does display correctly in our LBL subtotal label. Great. Now I'm going to add another method down here that will calculate the tax, and I'm just going to paste this in from some code I wrote before. Private double calculate tax, passing in a tax percentage and the tax amount. So in order to use this now, I'm going to add a new variable there, and then I'm going to calculate this by calling calculate tax and passing in our tax percentage, which should be US tax amount, and then also the tax amount, which in this case is the subtotal. Now I also want to make the appropriate change in my display result method as well to accommodate this, so that I can display the tax on screen. And I'm going to run the application, and notice that I get an error. The reason why this didn't work is because we didn't modify the call to our method. what I need to do is back up here and pass in the tax. Now let's run the application again. Seems to work this time, at least it compiles and begins to run. And notice that we get the subtotal and the tax amount, so it seems to work. Now let's take a short aside and talk about how we called, or rather used, the methods we built. To use a method, we use its name, and then we create an open and closed parenthesis. Between the parentheses, we'll type the actual value or variable name of any values that we want to pass as parameters into that method. Now, as we just learned, we must pass the exact number of parameters in that were expected by our method's declaration. In the case of a method that returns a value, we can set a variable equal to the method call, like we've done here and here. And when the method finishes executing, whatever the value is returned by the method will be stored in a variable. However, just to let you know, I could, here, let me just copy this. I could do that. What's the difference? I omitted the subtotal equal part, so essentially I'm ignoring the value that is returned by the method. The method tries to return a value to the line of code that called the method. However, the value is simply ignored. It's not used and it's essentially forgotten about. And so that brings us to a best practice. Always capture the return value even if you don't plan on using it. So let's assume that you need to use a method that somebody else created and it does 90% of what you need for it to do. But it also returns values that you're not interested in. You should still go ahead and retrieve the value like we've done in this line of code, even if you have no intent of displaying it or using it in any future calculations. Now in our example, we needed to retrieve the value so we could in turn display it to the user. So that's how you call the method in that particular case. But let's go ahead and just get rid of that. Now to call a void method, you can do something similar like we've done right here. And since we don't expect a result from a void method, the best practice for non-void methods that we just spoke of a moment ago just simply doesn't apply. Okay, now that I think we've got a pretty good foundation, I'm going to move forward and finish the remainder of this example. But I'm going to pause the recording this time so you don't have to watch me type the whole thing out. Okay, we're back and a lot of work has taken place, so let's review what's happened. First of all, let's take a look at the btn US_click event where there are fewer lines of code than before. Now, how much less? Well, in all honesty, not a lot. But remember that this is a very simple example. The more sophisticated the application, the more benefit you could expect from breaking up some of the core functionality into methods. And I could have modularized the code a little bit more, but I decided against it. Maybe this is something that would be a good extra credit opportunity. Using methods make this example as small as possible from a lines of code perspective. Let's take a look at what's common across all three of our button click events. First of all, we grab the weight and the distance from the user's input and put them into the appropriate variables. Now that's pretty much similar to what we've done up to this point. Next, I called a single method, calculateAmount, passing in the weight, the distance, and the tax amount. Let's look at the calculateAmount method. The bulk of its functionality is determining the subtotal, the tax, and the total amounts. Next, it calls the displayResult method to display the results on our form. Now, this is very similar to the code that was copied to all three of the buttons when we first created this application. I just took all that code, consolidated it all in one place. Now, remember, if you find yourself writing the same code in more than one place, or copying and pasting large blocks of code into several places, you might want to catch yourself and pull all that common code out into a single method like I've done here. The other interesting thing about calculateAmount is that it delegates the determination of the subtotal, the tax, and displaying the values on the screen to other methods, so methods can call other methods. And there's pros and cons to this approach, but for now, let's just leave it this way. The displayResult method stayed pretty much the same as the previous example that we looked at earlier in this video. And the remainder of the methods simply calculate the tax, the subtotal, as we saw were referenced from the calculate amount method. So now let's run this application just to make sure it works. And it seems to at least calculate some numbers. We would obviously want to check to make sure those numbers are correct based on what we were expecting, but it looks pretty much like it's working. Now you'll notice as we went through this video and the previous videos that I run the application that I'm working on often to make sure that it works. This is a quick way to validate the changes that I made actually work and that I don't code for a long period of time building a lot of code on a faulty assumption or premise. You should get in the habit of writing a little code, then testing it, writing a little more, then testing it. I'll use my sample data 8 and 9 and run it each time so that I can kind of keep track of the results. I don't just randomly go in and choose new numbers every time to make sure that nothing has really changed. This is a simple form of what's called regression testing. But so far, so good, so let's move on. Let's test our approach to how we structured the code and assume that we need to make a change to the calculations. Now how much impact will a change request have on my code? Let's say when we change the way the subtotal is calculated like we did in the very first example and multiply the weight times the distance times 0.5. So let's find the code where that exists. And it looks like I already have times 0.5 here, but let's just change it back to the full amount. Pretty much the same type of thing. All I had to do in order to make a change to the subtotal was change it in one place. I didn't have to jump to various places throughout my code to make the switch. Instead of changing 3 lines of code, at least in this simplified example, I'm only changing 1 line of code, and each of the button click events that use calculate subtotal method will benefit from this change. I basically eliminate the possibility of forgetting that I need to make changes in several places. So now that I've made this little change, let's rerun the application, use my sample data, and validate that the change didn't break anything, but it works correctly the way that we intended, and it seems to. Now you might be wondering how I decided to break up the application into a method that in turn called other methods. And that's a very good question, and that really comes with more experience. As a general rule, each method should only do one thing. You should be able to use just one sentence to describe what a given method is trying to do. If you ever have to use the word "and" when describing the functionality of a method, that might be the first clue that there's an opportunity to break up a method into more than one method. For example, I have this method calculate subtotal right here. I could say the calculate subtotal method returns the subtotal of the values to be shipped. Now, if I were to say the calculate subtotal method returns the values of the items to be shipped and the tax, I might catch myself and say, and the tax, well, maybe I should break that out into its own method. And as I've already indicated, if you find yourself typing out the same lines of code over and over again, you might think to yourself, that might be an opportunity for me to break that out. Take that code and put it into a single spot rather than just having the same code in several different spots, so that if I need to make changes to it, I'll just need to make changes in one place. So if you need some of the concepts reinforced that we talked about during this video, I would encourage you strongly to read the lesson material I supplied for lesson number 10 and the extended readings. Thank you.